Previously we have discussed about power supplies, that is rectifiers. That is, rectifier means half wave rectifier, full wave rectifier. These things we have seen previously, and the filters. So the voltage applied from that rectifier will be pulsating, and this pulsating DC can be remove its pulsation by using filter, that is capacitor filter, inductor filter, LC filter, etc. But again, there may be our output voltage may not be constant, that is output voltage may depends upon the input voltage variation, that is there can be input voltage variations and there can be load variation. Load means our current drawing device may vary. So depending upon all these, there will be variation in the output voltage of our DC source. To avoid that variation in the output voltage of the DC source, we require a regulator. That is, regulator means a controlling. We are controlling this thing. Such a regulator is a symbol. Such a regulator is a Zener voltage regulator. So here we are studying the simplest of it is a Zener shunt regulator. Zener shunt regulator. This is the Zener shunt regulator. That is, it is coming in parallel with load. Zener diode is coming in shunt, in parallel with the load. Shunt means parallel. So that is why it is called a Zener shunt regulator. So this is the diagram. So here this is the Zener diode. I have told you already there are different types of Zener diodes are available. So this can be a 9 volt Zener diode. 9 volt. Assume it is a 9 volt Zener diode. So, and this is a supply voltage, and Vs should be higher than this 9 voltage. It should to work this as a regulator. Vs, that is supply voltage. This can be from the output of a rectifier or a output of a filter, that is unregulated power supply. So if you are using this such a setup, here you will get 9 volt DC irrespective of the variation in the input voltage. Irrespective of the variation means it can vary from 9 to 12 or 15 like that. So if you are giving 9 volt here, suppose here you are giving 9 volt here there will be some drop across the RS, there will be some drop across the RS. So normally we will get a 9 volt output itself, there will be some drop, but to work this as a regulator, this voltage, the Vs should be higher than this 9 volt by some amount. So it can be 10 volt. So 10 volt means 10 volt, if you are applying Vs equal to 10 means this voltage is 9. So this is the voltage of the RS is 1. So the remain as per KVL, if you are applying 10 volt here, 9 volt will come here, 1 volt will come here, and you are getting, as the load is connected in parallel with the Zener, you will get 9 volt here. Suppose you are connecting 10 volt here, 2 volt will come here across RS. So RS is a dissipating element. So if you are increasing this to 12 volts, there will be 3 volt across the RS. So in that way the dissipation increase if Vs is varying. So there can be, so RS should be designed in such a way that it should handle the required power, otherwise this RS will get damaged very easily. So we can see a Zener diode provides a constant output voltage when operated in the reverse breakdown region. That is, we know these normal diodes will work in the forward bias, and Zener diode, I have explained to you the characteristics of the Zener previously. So Zener diode has a reverse breakdown region. So when it is working in the reverse breakdown region, then only it will give a regulated output. In the forward mode, it will have a conduction breakdown voltage of 0.7, and in the reverse mode it will have that respective Zener voltage. So when operated in the reverse breakdown region, irrespective of the current through it and variation in the applied voltage. That is, irrespective of the current through it and the variation in the applied voltage, it will provide a constant output voltage. Then here Zener is connected in parallel to the load. That previously I have told you, Zener is connected in parallel to the load. Zener is connected in parallel to the load. Hence it is called as shunt regulator. RS is known as a series current limiting resistor. That is, here this RS is a series current limiting resistor. RS is a series current limiting resistor which is used to limit the current in the circuit. The output is taken across the RL. That is, output is taken across the RL means it is actually the load. Then ensure that Vs is greater than the Zener voltage to keep Zener in the breakdown region. That I have told you already. Vs should be higher than this to ensure this in the breakdown region. Then design of a Zener voltage regulator. How now let us see how we can design a Zener voltage regulator. For acting as a regulator, Zener diode must be operated in the breakdown region or regulation region. For acting as a regulator, Zener diode must be operated in the breakdown region or regulating region. Zener current should be maintained between Iz minimum and Iz maximum. That is, there is a Zener current. So this is the Iz. There should be a minimum value of Zener current and a maximum value of Zener current. This minimum value means minimum value is to ensure the regulation, and maximum value means there will be a maximum value, otherwise Zener will get damaged after that value. Then so Zener current should be maintained between Iz minimum, Iz maximum. That is, here Iz minimum, minimum Zener current are required to maintain the Zener diode in the on state, that is the Iz minimum, and Iz maximum, maximum Zener current, that is the Zener diode can conduct without being damaged. That is, if you are using beyond that value, if you are operating the Zener beyond Iz maximum, Zener diode may get damaged. Then the design of a Zener voltage regulator. Again, the design of a Zener voltage regulator. Here you can see Zener diode is selected in such a way that its maximum power rating is not exceeded. Zener diode is selected in such a way that its maximum power rating is not exceeded. That is, if the power limiting exceed means that diode may get damaged. So if maximum participation is given by Pz max and the Zener voltage means this is constant. Vz is normally constant. So Pz max, from this equation you can see that Pz max is equal to Vz into Iz max, or Iz max, maximum Zener current. That is, this is maximum Zener current is defined by Iz max is equal to Pz max by Vz. Vz is constant. That is, here Vz is 9 volt. We have seen an example, and there will be a maximum value of Pz, and the minimum value of the applied input voltage, that is the minimum value of the applied input voltage, that is, this is the Zener current. It has got a maximum value and a minimum value. So the maximum value is find out by that method, and here this is the Vs. Vs means the applied voltage. It should be higher than this by around 25% for safe working. So here the minimum value of the applied input voltage Vs minimum must be higher than Vz, preferably 25%. Preferably, it can be higher than Vz by 10% also. If that is also sufficient. 10 or it should be higher than that only. Otherwise it won't work. So there should be a minimum value of the load resistor RL minimum to ensure breakdown. That is load resistor. That is, here this is the load resistance. If there is no load current, this is the load current. If there is no load current means there will not be any current through this device. So there should be a minimum value of load current also. There should be a minimum value of the load resistor. Is is equal to Vs minus V0 by Rs. Is means the current through this Rs is current through this RS is Vs minus V0. That is always Vs is higher than V0. So this is Vs, this is V0. So always Vs will be higher. Vs minus V0 is the voltage across this RS, and Vs minus V0 by RS is the value of the Is, the value of the Is. So Is Vs min and IL IL max, the maximum load current is equal to V0 by RL minima, V0 by RL minima, that is maximum current when RL will be minima. And again the value of the Iz minima is given by the value of the Iz minima Is minus IL max, and the value of the Iz max is Is minus IL minima, that is here you can see that Is minus, this is Is. So as per KCL, Is plus Is is equal to Iz plus IL. So if this is higher, this will be minima, and this is lower, this will be maximum. So this is equal to Is is equal to Iz plus IL as per KCL. The next equation is coming depending upon that KCL. So Iz minima is equal to Is minus IL max. Iz max is equal to Is minus IL minima. The value of the RS is selected such that it allows a current of Iz minima to flow through the Zener diode when the load drawing a maximum current. That is, it is the design of this resistor will be, the design of this RS is designed in such a way that it will give a minimum current, and a maximum current. That is, the diode is operating in the reverse breakdown region, then only we will get a proper regulated output voltage. Here you can see there are two terms known as line regulation and load regulation. To describe the performance of a regulator, there are two terms known as line regulation and load regulation. So this is again the setup is same. So line regulation means how we are measuring the variation of the output voltage with respect to the variation of the input voltage. That is, here we are in the previous example we have told you, we have seen the input voltage may vary from 9 volt to 12 volts. That is, it can vary from 9 volt to 12 volt. The output voltage is 9 volt. So if output voltage as the input voltage increases from 9 to 12, there can be a variation in the output voltage. It may not be fixed. Always there will be practical errors will be there. So if the output voltage is 12 volts, the output voltage if the input voltage is 12 volt, the output voltage may be 9.1 instead of 9. If the input voltage is 10 volts, the output voltage may be 9. So there can be a variation in the output voltage. Even if we are using a regulator, there can be some variation. So line regulation means it is a measure of how the output voltage varies with respect to the variation in the input voltage. So here there is a load resistance RL kept fixed, and the input voltage Vs is varied. That is, input voltage vary within the limits. As the input voltage Vs increases, Is also increases. Vs, when we are increasing this, Is also will increases. This increases the current through the Zener, thereby keeping the load current constant. Thus the output voltage is constant. But there can be, as the input voltage Vs decreases, Is is also decreases. So this is actually the working. But there will be practically there will be some variation in the output voltage. So line regulation is actually the delta V0. That is, the output voltage even if it is designed for 9, there can be a change from 9 to 9.1. If the input voltage is changing from 10 to 12, there can be input voltage is changing from 10 to 12, but the output voltage is changing from 9 to 9.1. So, the delta V0 is 0.1 divided by delta delta V in is delta Vs is 2. So, that is 0.1 divided by 2 into 100% is the line regulation of this. Ideal regulation is 0%. Ideally, the regulation is 0%. So, that means even if there is any change in the input voltage, output voltage change should be 0. But practically there will be some change will be there. Then the other term is load regulation. Load regulation means again the setup is same, but here the input voltage is same. The input voltage is same, but the output voltage will vary. Output current will vary. Output current will vary. So, here Vs is fixed and IL is varied by varying the load resistance. This is fixed and IL is varied. In the absence of the load resistor, that is, in the absence of this load resistor, output voltage is maximum. In the absence of the load resistor, when there is no load resistor, there will not be any load current. So, that is known as the full load, V0 load. That is, there is no VNL means when there is no load resistor, the output voltage will be maximum. The output voltage is maximum, and that is known as V0 load minus V full load. V full load means when we are designing this regulator, it can be used to we will design it for 100 milliampere or 1 ampere like that. 1 ampere like that. So, if it is designed for 1 ampere means the V full load is the voltage at output when 1 ampere is drawing through this resistor. If it is designed for 100 milliampere means V full load means the voltage at the output when 100 milliampere is drawing through this resistor divided by V full load into 100% is the expression for the load regulation. So, that is all about the regulators. We can see next topic in our next class. Thank you.